When you're in a situation where there's just a ton of certainty, it's actually pretty easy to do strategic thinking. You look at the variables, you make a plan, and you implement it. It's like if you want to cook a dish you know how to cook, get the recipe, buy the ingredients, cook it, you're out. But a new chef creating a brand new dish has a totally different process. That chef might start by getting inspiration from what other chefs have done, and then using their expertise to assemble a bunch of interesting ingredients that might work well together, and then trying it and tasting it and getting lots of feedback from other chefs, and then essentially iterating their way to a successfully brand new dish that they didn't even have a conception of before they started.
And so redesigning whole classrooms and schools for this new blended learning world is a lot more like that chef creating that brand new dish than you or I just simply following directions and roasting a chicken. There's just no playbook about how to do this, and to be frank, a lot of the software and hardware ingredients aren't all there yet.
But this does not mean you can just be wildly experimental and throw it up to saying, oh, Michael and Brian told me to iterate, right? It's more like the scientific process. You create a thoughtful hypothesis, and then you figure out a way to test it in the quickest and easiest way possible. And then based on that data, you pursue one of two paths, either more of what you've been doing or less. It's a rigorous thinking process.
There are several bodies of thought around how to test, learn, and adjust as you build a solution to a problem. Design thinking, lean startup methodology, and discovery-driven planning. These are each important topics in their own right, but here, just for time's sake, we basically combine them into a survey of these ideas to help give you a process for how you're going to innovate in your own context. Now, the nice thing is that if you followed up with the assignments throughout this course, you're actually going to be in great shape because they've paralleled these processes already. So let's dive in. When you're doing something new in education, but that's relatively similar to what you've done before, the process is actually pretty straightforward. Just think about purchasing a textbook. You get a group of people together, you evaluate your options, and you pick the textbook, and then you roll it out in the classroom like you've always done.
But if it's uncertain conditions, it's totally different. Think about Steve Jobs and Apple launching the first iPod. If they had taken the playbook from Sony on launching the Walkman cassette player, they would have missed huge opportunities that this new model allowed for them. Things like the iTunes Store, or even the phenomenon of streaming music, or the marketing idea of 40,000 songs in your pocket.
Exactly, and Summit Public Schools, one of our protagonists, is a lot closer to Apple than the textbook. When they were implementing a model with playlists, that's something that really had not been done before in education.
So what change in iteration usually looks like in most schools, and certainly the schools that I worked in, is that every year in August we would launch something new. And it's something that we worked over the summer to plan for and create, and whether it's a teacher in their classroom or a school, we'd launch it, and then we'd run it for the entire year. And we wouldn't change anything during the year. And honestly, we wouldn't really gather data about how it was working or not. Sometime in the spring, as we were thinking about the next fall and staffing and budget, we'd be like, should we keep doing that? Yes, no, maybe, whoever was at the table, it was sort of arbitrary how it'd be decided, and that's kind of what happened for the next iteration. It wasn't disciplined, it wasn't focused, it wasn't data-driven. So we knew we needed a different process. And so we found and adopted the Lean Startup by Eric Ries as an iterative process for what he calls the build, measure, learn cycle, where you actually build something, but you're intentional about your build. What problem are you trying to solve? You, in advance, say, what am I going to learn from this? How am I going to measure if it's successful? And then you actually intentionally gather that data, measure it, learn from it, and then you don't just go do it again or not. You actually iterate on what you've done based on that measurement and that learning.
So when you're implementing something in education that's totally new and unfamiliar, we suggest a framework that has 6 key steps. The first step is to get clear on your objectives. You need to know your desired goals.
Then figure out how you're going to measure results. How will you know if you're succeeding or failing? And what data will you need to be measuring?
Step 3 is to commit to action. The learning happens by doing.
So you create mini tests that allow you to figure out what is or is not working.
And then you collect feedback from the students and teachers involved.
And lastly, you keep iterating your way to success by doing more of what's working and tweaking what's not. being clear on your objectives is essential so you're not just floundering your way through this process. And remember, your objective is not about technology itself. You're not just saying, my goal is to have iPads in the classroom, because that's self-referential. It's always about the learning you're trying to create and the way that you think technology will help you get there.
In step 2, figure out how you're going to measure your results and figure out what's your data that you're actually going to use so that you know if you're being successful or not. Now, when we talk about data, we don't just mean test scores. You can use those, but you can also use things like student engagement, how much time are they spending with teachers, factors like that that lead you to understand if your model is actually being successful.
Committing to action is really important because this can't just be a theoretical exercise. It's like a chef, when they get their ingredients together, at some point they have to put it in the pan and see what happens when you introduce heat and how the flavors meld together. And in education, that happens when you put this in front of real students. You have to be willing to get your hands dirty and try these ideas. Otherwise, it's just all an exercise of thinking on paper. So roll up the sleeves and try this work as part of committing to action.
The important thing, though, is that as you try out these ideas, you're not doing so in these big, high-stakes rollouts that have just huge risk if you get it wrong out of the gate. Instead, you want to really create mini tests in step 4 that are just really cheap, low-cost ways to test out ideas and prototype really rapidly in what a lot of people call a minimum viable product, or an MVP, basically a way that allows you to test really, really quickly whether something's going to work so that you have time to iterate.
It's like if you're designing a new phone interface. You don't build the whole software code and release it to the world. You might start by taking your phone and just sticking a Post-it note on it and drawing the sort of experiences that you want the students or the users to have, and then you can tear through Post-it notes. Before you even write a line of code, you can learn a huge amount.
One example of how we learned that prototyping is so important to the innovation process is when we didn't do it, actually. It's when we decided to go through every single step and get ready to release a new tool for our students without going through and examining what it would look like for one student. And halfway through Thanksgiving break, 30 hours into the project, I'm like, 2 people are on the phone, and we're like, it doesn't show up on a student's computer, I don't know why. The links aren't working and I'm not sure why. So then we had to stop. We had already created something for 200 students at that point, and we had to go back every single step and see where we went wrong. And in those hours of recorrection, it was a lesson over and over again. Great, this is why you do small batch testing. This is why you have to prototype right away, because you are able to get a tool into the hands of the users as fast as possible, and then you can iterate from there on out instead of having to spend any time fixing what doesn't make sense.
Typically in education, when we try something new, it's a multi-year process with huge planning teams, and we spend a ton of money and do all these things and then finally give it to students to see if it even is a good idea or not. And it's almost the opposite of an MVP. And in comparison, there's a school that we support at Silicon Schools. It's called Caliber Schools, and they took a much more MVP approach. They decided to start a summer prototype to try out their ideas before they even opened their school. Caliber wanted to test out what kinds of support students would need to be successful in their model, or whether students without much computer experience could be taught to code, or what kind of teachers could be most successful in their model. By building a real laboratory, they could test all these ideas out in person versus just a hypothetical argument on paper.
And just think about how much easier this is to do when you're doing it in a summer school, outside of the normal school environment. Just as the theory proves true or doesn't prove true, you can make adjustments much more easily. And after school is actually a very similar space for you to be able to try these sorts of ideas out and have that freedom to iterate.
And when you're in this prototyping stage and you're coming up with new ideas, remember how important it is to get lots of different people as part of this process so you can actually think outside of the box.
I think the beauty about prototyping is that you don't need that many tools, you just need a mindset and you need a process. And so really the way we started prototyping is we took butcher paper and we just threw up slabs of butcher paper on a wall, and we said, identify the problem, look, anything that bothers you, just write it up here, and anyone who has a solution to it, do the same. take a marker, write, go. Use your brains, be creative, let's be a team. And then as we saw the problems formulating, then we just made mini teams and we thought through different problems, came up with different proposals, brought it back to the team, and enacted it in within a week. So that was a really powerful way for us to ensure that the teachers were the drivers of innovation and the teachers were a part of the design process because they were the ones who were best able to identify the problems right off the bat.